All right, let's dive into a subject that's, well, the very foundation of pretty much all higher mathematics algebra. But here's the thing, instead of thinking of it as a scary bunch of rules, let's treat it like we're learning a new language, a universal language, actually. And by the end of this, I promise you're going to be well on your way to speaking it. So, why on earth do we start throwing letters into math problems? What do X, Y, and Z actually mean? It's the question that trips a lot of people up right at the start. But trust me, the answer is way simpler than you think. These letters, they're just the alphabet of algebra, and we're about to decode them together. So, here's our game plan. We're going to start with the absolute basics, the building blocks of algebra. Then, we'll see how to put those blocks together to form words, or what we call expressions. After that, we'll get into the grammar, the rules of how to use those words. And finally, we'll put it all together to make things neat and simple. Ready? Okay, first step, section 1, algebra's building blocks. Think of this as learning the ABCs of our new language. Once you get these down, everything else just starts to fall into place. The very first letter in our algebraic alphabet is the variable. You've seen them everywhere, X, Y, Z. Think of a variable as a placeholder, like a little mystery box that's holding a number for us, but we just don't know what that number is yet. Its whole job is to stand in for a value that can change. Next up, we have the constant. And this one, it's super easy. A constant is just a plain old number. Its value is fixed, it never changes, it is, well, constant. You know, like the number 2, or 5, or 10. What you see is exactly what you get. And our third and final building block is the coefficient. This is the number that's right next to a variable, the one that's being multiplied by it. You can almost think of it as the variable's sidekick. It tells you how many of that variable you're dealing with. And boom, here's where it all comes together beautifully. Just look at the expression 5x plus 3. That x is our mystery box, the variable. The 5 that's attached to it, that's our coefficient, telling us we have 5 of those x's. And the 3 hanging out by itself, that's our good old constant. See? 3 simple parts, all working together. All right, on to section 2. We've got our alphabet down, now we can start putting those letters together to form words and even sentences. This is where we combine all those individual pieces into something that actually means something. And that brings us to the algebraic expression. It sounds fancy, but it's really just a mix of the variables, constants, and coefficients we just talked about, all connected with operations like plus, minus, times, and divide. It's basically a mathematical sentence. Now, inside that sentence, each little chunk that's separated by a plus or a minus sign has a name. It's called a term. So if you look at our example, 2x plus 3y minus 5, the terms are 2x, 3y, and, importantly, negative 5. Each one is its own little self-contained package of information. Now listen up, because this is a really important rule. You can't just combine any old term you want. You have what are called like terms and unlike terms. Like terms have the exact same variable part. Think 2x and 5x. They're in the same family. Unlike terms like 3x and 4y have different variables, so they're in different families. And here is the golden rule. You can only, and I mean only, add or subtract terms that are in the same family. And that rule leads us perfectly into section 3, the rules of operations. So if expressions are our sentences, then these rules, this is the grammar. This tells us how to actually use those sentences correctly. The basic operations all follow these really clear patterns. For adding and subtracting, it's just like sorting your laundry. You only combine the like terms. See how the x terms go together and the y terms go together separately? Now, for multiplication and division, it's a bit of a different dance. First, you deal with the coefficients, then you deal with the variable's powers. When you multiply, you add the powers. When you divide, you subtract them. These are the fundamental rules of the game. Oh, and speaking of powers, let's just do a super quick refresh on what an exponent even is. It's really just a bit of a shortcut. It's for repeated multiplication. So instead of having to write out x times x times x, we can just write x to the power of 3, or x cubed. It just keeps our work looking a lot cleaner. Okay, this table might look a little intimidating at first glance, but it's basically the official rulebook for exponents, and there's a really simple logic to it. Look at the product rule up top. When you multiply terms with the same base, you just add their exponents together. The quotient rule is the opposite. You subtract. And check out the zero exponent rule. This is a fun one. It's a universal truth in math. anything at all to the power of 0 is always 1. Always. These rules are your best friends. They're shortcuts that make really complex problems way, way easier. And here we are, our final section, making expressions simpler. This is the payoff. This is where we take everything we've just learned, the alphabet, the words, the grammar, and we use it to clean up messy expressions and make them look neat and elegant. So the first big skill here is simplification. This is basically just algebraic housekeeping. You're tidying up by combining all the like terms. So you gather up all the x's, you gather up all the y's. 3x plus 4x becomes 7x, and 5y minus 2y becomes 3y. Look at that. So much cleaner and way easier to work with. And the second core skill is factorization. You can think of this as doing simplification, but in reverse. Instead of putting things together, you're looking for what the terms have in common and pulling it out. In 6x plus 9, what number goes into both 6 and 9? 3. So we pull that 3 out front and see what's left behind. It's a really powerful tool for seeing the hidden structure inside an expression. So let's do a quick recap. You now have a complete starter algebra toolkit. You've got the building blocks down, you understand that absolutely crucial difference between like and unlike terms, you know the rules for all 4 basic operations, plus the laws for exponents, and you have the 2 most important skills, simplification and factorization. And this is the main takeaway, really. What we just went over isn't just a bunch of random rules. This stuff is the absolute bedrock foundation of algebra. Once you get really comfortable with these fundamentals, I'm telling you, the rest of algebra, and even calculus and beyond, it all becomes so much less intimidating. So, now that you've got this solid foundation, the question is, where do we go next? What's the next step on this journey? Should we take these new skills and use them to finally solve for x with linear equations? Or should we see what these expressions actually look like visually when we turn them into graphs? The next chapter is all yours.